So currently we have a bug in the program that seems to be putting it into an endless loop. And I begin to realize that when I copied and pasted the code and just try to adjust this loop to generate the beeps according to these frequencies, what happens is that initially the program was using register BL as a counter. But it is in conflict with EBX because BL is part of EBX and we're also using it for the duration. So I'm changing BL in two places right here to register CL. Alright, so CL, and now we should be able to, after this adjustments, in fact CL is a popular register to use it as a counter. That's where ECX gets its name. This is basically a counter register. So okay, so we have 16 the length of 16 frequencies. Let's just make it recognizable. Let's change it to 3. Okay, and we should hear 3 beeps and we should exit normally. So this time I'm going to again press Ctrl F5 to launch the program. And there was exactly 3 beeps generated. Okay, so this was the problem that essentially we had a conflict between register BL and EBX. So now this is obviously the loop. We can say loop to generate beeps from the array of frequencies in memory. We can also sort of copy and paste this loop and make it work for us above here. We can essentially initialize these frequencies to certain values. Let's just say that what we need to do, we need to ask the user for frequency values. But I'll just try to compute them in memory for now. So we're going to start with the same thing. We're going to set the counter of frequencies. Then we're going to load the address of this array into register ESI. And then instead of getting the frequency, let's recalculate it. So we'll say we're not going to call beep inside this loop. Instead, we can perhaps start with register EAX of a certain value. Say 250, for instance. Move into register EAX. Hard-coded frequency, and this we can say this will be our base frequency. Okay, and what we can do is just we can add EAX. We can say double frequency, and we're just going to update frequency inside of our array like this, right? So we're just going to set each frequency according to the recalculated value. So this way we can update it. So then we're going to increment our pointer and also decrement the loop counter, and as soon as the loop counter becomes 0, we're going to jump out of it. In fact, it's probably a good idea to replace our labels corresponding to our loop to anonymous labels. There's really no need to keep specific names here. So this is a pretty distinct loop from here to here. So this is also comment gets outdated if CL is not 0, continue. Okay, and this loop the same way. I think that we need to replace it with anonymous label and jump backwards if we think that the loop should continue. So the loop counter is in register CL. Okay, so this time the program is going to set frequencies based on basically duplicating them, starting from hard-coded value to 150. Okay, so let's try like 5 beeps. So build this and run it. Okay, so that generates pretty annoying sounds. So we need to probably lower this, basically, maybe like divide this by half, like making it 1200, and see if we can make something more bearable. Okay, so within 5 values, this may be acceptable. So this is, and I need to spell this correctly as well, double frequencies. And of course, what remains to be done is to interact with the user and ask for the frequency values. So what I would advise to do, so let's go back to 16 of these values right here, because we may also need to add something like beep count, right? We may also need to ask the user for the how many beeps would you like. So here we can store it also as a byte and initialize it to 0, or I don't know, like initialize it to also to the length of frequencies initially. So this will be initialized to frequencies, and here instead of getting the length of frequencies, of course this has to be replaced by the value stored in beep count. Okay, so but that is important, that we actually ask the user. So here we need to have another part of the program, as the user how many beeps they want, right? And so and basically and store the value in beep count. We also need to validate that entered count is basically greater than 0, I would think, and count, let's just use this sort of like a pseudocode right here. The count is greater than 0 and less or equals our length of frequencies. Okay, so this is an idea. So right now, basically just keep it more, do it in a more generic way. Just ask the user how many beeps you like and store it here, and then use it as the value. So for the beep count, again, so we're going to use instead of loop counter hard-coded to the length of frequencies, we can now use the value entered by the user. So we can respect here user request. So once again, I'll just probably just reduce it by, by 2 again. So this, we can make it like 60, and then we can make it maybe 8 beeps. Let's see if we can tolerate 8 beeps right here. Okay, so something like this. Anyways, this is just a prototype, but you can see that, of course, you can, once you implement interaction with the user, you can be asking the user what should be the frequency values, and you should prompt the user in what units are you asking them to provide the values. So this is like, it's basically we're rotating somewhere around 1 kilohertz, so you can just tell the user to try different values in that range and see, and you can play with certain values. So I am highlighting the things left to do with the to-do comment. And I think one more thing that's specified right here is to basically to display tone frequency and duration. Okay, so we can display display this. So this, I think, should occur as we generate the beeps, perhaps before the beep is generated. As soon as we get the frequency, we can essentially add this comment here to do. One more item to do, and display the tone frequency and duration on the console screen. This is something that we can easily insert into this section of the program. Just basically display the values that are already loaded into these two registers and print prompts for what these values are. Of course, we already discussed that right here we need to display the error code. Getting the error code in EAX is already done. All you need to do is just convert the register EAX value into an integer and display that there was an error code, and that's the code. The next item is to call the sleep function to delay the beep. Basically delay the progression of the beeps by a certain time interval. So what we can do here is that we can we can push EAX before we call, say, preserve frequency. Okay, and then after making the call and when everything is okay, we can pop EAX like this. Okay, so we just preserve EAX and then we restore the frequency, and we can go to sleep for this same exact time. Basically, we can push EAX one more time. This will be sleep interval in milliseconds, same unit of measurement, and we can call sleep, which requires 4 byte size parameter, and of course we're going to declare sleep at the top as another extern. Okay, and this is also a near procedure because everything is a near procedure in a flat memory model. So this is yet another example of API call. So let's see if this actually works, right? But this is how you could rearrange this, but this is how you can add a sleep call to the logic of this making beep. So here the important thing is that we want to preserve the frequency because of course beep, right? Because beep changes EAX, so we have no other choice but preserve it. And to preserve it, very typical thing is you just push it on the stack, and when you're done preserving it, you just pop this register, and the sleep is expecting duration for a sleep interval in EAX. So this is one single parameter for this function call. We have seen sleep call in our C code right here. So this was sleep milliseconds, and this is how sleep looks like in assembly. This parameter milliseconds is pushed on the stack, and it's a integer, a double word value that we just save on the stack. So let's see if this works as expected, and see if there are any other things left to do here. Okay, is this it? So let's see. I just want to verify that everything is working correctly. So let's see what changes we made, and if everything is correct. Let's just change the hard-coded values. We can use our constant memory segment to say that we want maybe to say default frequency will be double word, and set it equal to 500. Okay, so this will be our default frequency. And we can also have default frequency array size, and we can set it to perhaps 3 for now. And so instead of hard-coded 8, we can use default frequency size like this. And okay, so this should be now set equal to 3 right here. Right, so this will be 3. And I want to, one more time, I want to put this through a test. Default base frequency also, let's add that. Default base frequency. We are going to set this equal to right here. We had this at 60, so I'll just change this to maybe 100 for the purpose of this test. And of course, I'll replace the 60 with the base frequency. I'm sorry, the base frequency should be this. And of course, then I need to fix these numbers right here, like this. Okay. So just want to do some testing, and that's why I added these values. And of course, we don't have to even reserve anything here. We just basically say equals, right? We can replace these D words with equals, and that would be assembly time parameters. Okay, so those are very typical default values that you want to use as constants in your code. And I just want to make sure that after making these adjustments related to EAX, that we're doing the right thing. So let's see, we'll start testing it now.